Hi, Mohammad Ashraf. How are you doing? So, good afternoon to all you guys. How's everyone? All right. So, first of all, let me welcome you guys to the Unacademy JEE English. This is a brand new channel by Unacademy, which is India's largest online learning platform for IIT JEE. And here, everything is being taught to you completely in English. So, this is a series that I host for class 11 students or 2022 aspirants of IIT JEE. Hello, Rohit Rao. So, the topic that we are discussing right now is work, power, and energy, and this is lecture number 5. Today, we'll be talking about the applications of work energy methods. Good evening, Rishabh. How are you doing? All right. So before we get started with today's lecture, let me introduce myself one more time for those of you who don't know me. Yes, I know it's Wednesday. All right. So my name is Rohit Dixit, and I studied mechanical engineering from IIT Delhi. And for almost past 8 years, I've been teaching physics for the IIT JEE. All this teaching so far had been offline. This is the first time that I'm teaching online. In this lockdown, all of us were forced to move online. So this is my first online venture. I myself was All India rank 447 and All India rank 192 in the two stages of the IIT JEE exam that I took. Now, I also qualified ATSC Stage 2 and I was in the top 1% in the NSEP, which is the National Standard Examination for Physics. I've already coached many students to top ranks in the IIT JEE from the offline setups. I hope to continue doing that online with you guys from here. So how do you guys ensure that you also get your top results in the JEE exam? So you should be getting your Unacademy subscriptions. This subscription will help you in a lot of ways. So first of all, you get live classes where you get to interact with your educators. So even in this lockdown period, when you can't attend live classes offline, you can always keep studying online with the Unacademy courses. Now, these courses also have live polls and leaderboards, which keep the classrooms highly interactive. Now, you also get a test series and you have analysis sessions, which will help you identify the areas where you are lagging behind and the scopes of improvement. Now, you also have live doubt clearing sessions in all these courses, and as a matter of principle, every fourth session has to be a live doubt clearing session in all Unacademy courses. So trust me, with the Unacademy courses, your doubts will never build up. You will keep studying non-stop and you will be well prepared for this competition. Now, on top of all these benefits, Unacademy provides you the opportunity to study from the best educators all across India from the comfort and safety of your home. Now, so how do you get this app? Very easy. First, you need to install the app, and once you've done that, go to the plus section of your app, select your goal as IIT JEE, and click on that Get Subscription button. When you click on that Get Subscription button, you will be asked about a lot of plans. So these are the two plans that are most relevant for class 11th and 12th students. So this for 12th and 12th pass, and this would be for 11th students. Now the fees here is been kept very competitive compared to what you guys must be paying offline. So offline, anywhere you guys would pay at least 4 to 8 times this fees. And on Unacademy, you are getting the quality education, same quality content and guidance from experts at a very reasonable price. And it will be made even more attractive if you use this code RD Live. This is my code. If you use this code, you will get a flat 10% off on all your subscription fees. So do you know anything about preparatory? So you're talking about prep courses in IIT? Preparatory courses in IIT, is that what you're talking about? Those of you, by the way, who are following us on the YouTube JEE English channel should be connecting with us on the Telegram app using the link shown above so that you don't miss out on any of the lectures and sessions happening on the JEE English channel. Hi Nandita, how are you? Yes, so there is a provision that is for SC/ST students actually. So if they lag behind, they are getting a not good enough rank to qualify, but they are given an opportunity. They are enrolled in preparatory courses wherein they will study in IIT for 1 year, where they will be given some classes to prepare them for all the courses. And after completion of that 1 year, then they enroll in the actual BTech program. So that is what the preparatory course is all about. Okay. So why don't we get started with today's lecture? Today's lecture will be talking about applications of work energy methods. Okay, this is lecture number 5. So in the last lectures, we talked about the concepts of work, the concepts of kinetic energy, the concepts of potential energy. We talked about work energy theorem, and we talked about work energy theorem in two forms. So first form said that the net work done by all the forces acting on a body is always equal to the change in its kinetic energy. Then we also saw that some of the forces are conservative and some are non-conservative. So whenever you have a conservative force, the work done by a conservative force can be calculated by associating a potential energy function to it. So potential energy functions are nothing, potential energy is nothing, but it can be considered to be the form in which the conservative forces store energy whenever they do negative work. So if you include the terms of potential energy, then your work energy theorem takes a new form, which is like this, which says that work done by all non-conservative forces would be equal to the change in kinetic energy plus change in potential energy. Now here remember that you should be taking the potential energy due to all conservative forces. Okay, you should not be missing out on any of them. If in case you are only taking the potential energies due to some conservative forces which are commonly known, then here you will have to include the work of other forces. So plus work by other forces which may or may not be conservative. Okay. So whatever you have included here in potential energy, that you don't have to consider here. Whatever forces for which you are not taking a potential energy function. So there are often a lot of constant forces for which we usually do not take the potential energy functions, but they are also conservative in nature. So their work should be included if we haven't included the potential energy. So either include the potential energy due to a force or include the work done by that force in this expression, and this is how you will approach your problems. Okay, so this is the work energy theorem, and the sum of kinetic energy and potential energy are known as the total mechanical energy of an object. Now, why don't we start with a practice problem where we will see how to apply this. Okay, so this is what I have for you to get you warmed up. So this problem says that a block of mass 0.1 kg is released from a height of 4 meters on a curved smooth surface on a horizontal. Okay, now on the horizontal surface, the path AB is smooth and the path beyond B offers a coefficient of friction of 0.1. The total distance covered by the block on the horizontal surface before coming to rest will be. So that is what you have to find. So you've been told a block is being released from here. It is initially released from here. So it will move along this smooth curve part, hit the horizontal part here, and then it continues here. From A to B, the path is smooth. From B onwards, there is friction. So here you've been told the friction is 0, and beyond B, you've been told that the friction has a coefficient of 0.1. So up to infinity, let's say this region extends. So what will be the total distance that the block will travel on the horizontal surface? So total distance covered by the block, that is what you have to find on the horizontal surface. So this is a very easy problem, just to get you warmed up, just to show you one very easy use or application of the work energy theorem. Okay, so Rishabh is already trying. Let's wait for others also. Let's see who can give me an answer first. So again, simple problem, you should not have an issue. Yes, 41 would be the correct answer. Very simple problem. All you need to know is that here it has a potential energy of mgh. Whenever it comes to stop, let's say it travels a distance x on this part. If it travels a distance on x on this part, then I can apply the work energy theorem and I can say that work done by friction should be equal to delta K plus delta U. Now obviously delta K would be 0 because it starts from rest and ends at rest. How about delta U? Initially it had a potential energy of mgh. Finally it has a potential energy of 0. So work done by friction would be minus mu mgx. Okay, so the entire friction would be kinetic in nature because it is already moving. So this will be the work done by friction. It will be 0 plus 0 minus mgh. So that is how you calculate this. So this will tell you that x is nothing but h over mu, which would be 4 over 0.1. So x comes out to be 40 meters. Now the total distance traveled. Hello Pavan, how are you? So the total distance traveled by the block on the horizontal surface would be 1 plus 40. So S total would be equal to 1 plus x, which is 41 meters, which Rishabh said is the answer, and Rishabh is absolutely correct. So well done, Rishabh. Okay, so this was a very, very simple problem just to show you how you can directly apply work energy theorem. You realize you could have solved this problem using Newton's laws and your equations of kinematics, but using work energy theorem makes your solution very, very simple. You're getting a one-line answer in a one-line, single line. So that is the advantage of applying the principles of work and energy. As I told you initially also, work energy methods are nothing. They are just providing you alternate methods of problem solving. But you will realize that in many cases, work energy theorem and work energy methods are the most viable options, not only the easiest. So in most of the cases, this is the easiest way to solve the problem. In most of other ways, this is the probably only option to solve the question practically. Hello Osho Rishi, I'm good. How are you? So let's talk about another problem here then. So in this problem, you've been told that two blocks of mass m1 and m2 are connected by a non-deformed light spring on a horizontal table. Now the coefficient of friction between the two blocks and the table is mu. You have to find the minimum force which when applied on block 1 will move the block 2 also. So this is your block number 1. This is your block number 2. You have to find what should be the minimum force that I should apply on block number 1 which would move block number 2 also. So let's try this. All right, let's see if you guys can do this. Again, this is the kind of question which if you wanted to solve from Newton's laws would be very, very difficult, but you can solve this very easily using the work energy theorem. So Lokesh, you're covering each and every topic in YouTube, then what is the need for plus subscription? Please tell me. So Lokesh, the point is, yes, I am covering each and every topic on YouTube. In the plus subscription, these topics will be covered in a very similar manner. Just that there you will have more practice sessions, you will have more personal guidance. We will see those are regular sessions with regular students that are enrolled, right? So there you get DPPs, and the level of DPPs is increased slowly depending on your performance. So that just gives you a more personalized coaching, and that just gives you a more rigorous coaching. Okay, so that's the idea. Okay, there you have doubt clearing sessions also. So all those features you don't get here. So there you have regular DPPs, you have regular practice solving sessions, you have regular doubt sessions. So they just give you more rigorous and more personalized guidance. See, here on YouTube, I'm just giving you all the concepts. It is a generic guidance for everybody who wants to attend, right? Since we don't have a regular course structure, we don't have a regular pool of students, so it cannot be more personalized for you. Okay, so that is the only difference. As far as concepts are concerned, trust me, I will be discussing all the concepts equally, in equal details. There, of course, the amount of problems that you will solve will be higher. I will be giving homeworks, I will be keeping track of how you're doing in those problems and so on. Okay, so let's see if someone can find the answer for this. So how do you think you will approach this? Think about it. Think about it. What has been asked? You have to find the minimum force that when applied on M1 should be able to move M2. So what do you think you will have to do? No idea. Okay. So think about what the problem is telling you. Okay. So why don't you try? Why don't you try? Yes, Rohit, that is the correct answer. So the clue is think about when will M2 move? When will M2 move? Think about that. See, if the spring gets compressed, spring will try and push this M2, right? Whenever spring gets compressed, it will try and push the M2 mass. And what is the force that is stopping M2 from moving? It is the force of friction. So if the spring force becomes higher than the force of friction, then that will cause M2 to move. Now you have to make sure that you have to find the value of F that will ensure that spring gets compressed at least by that amount, whichever will be able to apply enough force on M2 so that it can overcome the friction. Okay, no Kapil, Rohit Rao gave the correct answer. The correct answer is mu g into M1 plus M2 by 2. Alright, no problem, Lokesh. Okay, so I hope you guys got the clue. You guys got the approach. See, whenever you are given a problem, you always think about it, what must be happening, why it must be happening, and how it must be happening. If you can understand the why and how of the problem, trust me, problem solving is not an issue. Second Newton method too, just to share a glimpse of that. No, 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 I won't even do that. Because that will be very, very complicated. Very, very complicated. I will have to perform integration and all also. Okay, so that'll just waste my time. If you want, maybe I can just tell you how you could have solved it. But we will just solve this using work energy. So think about the ability of F to compress the spring. By how much will it be able to compress the spring? Assuming that M2 has still not moved. Think about the situation, what will happen? So first you can obviously see that F should have to be greater than mu M1G, right? If F is less than mu M1G, then even M1 won't start to move. Okay, and the spring will never get compressed, of course. So one hint is when you are checking your answer that the answer has to be greater than mu M1G. Okay, so Kapil, in your case, the answer would not be greater than mu M1G, by the way. I don't know if you realize that. I mean, it's not necessary that it will be greater than mu M1G. It could be less than mu M1G also. The expression that you have given, Kapil. Okay. Okay, Asha. So I won't be able to comment on that much because I honestly have not really seen either of those books much. I don't recommend those books, any of those books much. Okay, so that is going to be a problem. But I think both are good enough from what I hear from the reputation. Both are all right. I just don't like too many books by Indian authors. The reason is that they often have a lot of errors, which may end up confusing you. See, in order to make things simple, sometimes they tell you slightly wrong things. Yes, I prefer HCV. HCV is a time-tested book. I prefer only time-tested, really authentic books which have absolutely no errors. Okay, so Mohammad Ashraf says, sir, I wanted to ask one question that I have taken an academic subscription before 2 days, but I will not good preparation online, then I can return an academic subscription. Please answer, give me okay. So I am not sure what you're trying to say. So I think you have taken the academic subscription, and but I will not good preparation online. Uh, so I don't know if you're trying to say if you can cancel the subscription in the middle, then I think it's better that you contact somebody in the technical side of the Unacademy uh, team. Okay, so you go to the app and you go for help there. Maybe those guys would be able to solve this problem, solve this issue, because I honestly don't have much idea about this. So Asha, yes, as I said, I prefer the book that I really recommend is HCV. Definitely, HCV is the book that you should be doing for problem solving. I think you could go for either of them. See, I don't like the theory in both much. Okay, so let's talk about the solution. And I think I don't really know about Arihant much. I have not seen that in too much of details. But as far as Cengage goes, I think some of these students, my students uh, earlier would get me problems, and I found a lot of errors in that book. So that is my feedback for that book. It has a lot of errors that need to be corrected. So if you have a book which has a lot of errors, it's better not to follow it because it will just end up confusing you. Okay, so as I said, eventually what you want is that imagine what will happen. Just think about the situation. Just think about what will happen. When you apply this force F, now you realize if F is greater than mu 1 mg, then obviously it will start to press this block, right? And let's say it will push the block, and as the block is getting pushed, getting pushed, now you realize it is feeling a force of spring also kx. So the force trying to oppose the motion is constantly increasing. As a result, what will happen is that the net force causing the motion will decrease slowly. Eventually the two forces will become equal, and after this point it will start to slow down and it will eventually come to rest after compressing the spring by some amount x. Now during the entire time I am assuming that m2 does not move. I am assuming that the block 2 hasn't moved, only this block is moving. So it starts to compress, but as it compresses, the spring is pushing it back, causing it to slow down, and eventually it comes to stop. Now, if whenever it comes to stop, this is the maximum compression that it can get in the spring. If at that point, when the spring has maximum compression, the force acting on this would also be maximum, right? It would be kx. And if so, please remember, let's just write that down. If x is the maximum compression in the spring, and kx is just equal to mu m2g, then m2 can just slide, can just move. If the compression is greater than this, then of course it will definitely move. Should we solve each and every problem in any book or randomly choose a problem? See, it's always better to solve each and every problem, Asha. Okay. Hi, Ashwin. So, as far as your HCB is concerned, I think the reason why I love that book is that the organization of questions is very, very good. The way the problems have been presented, so they start with very easy problems, and as the problems progress, they pick up the level slightly, slowly and steadily, and so it will start with problems which will be very simple, definition based, straightforward, formula based. So starting problems can all are almost your board level problems. Now the middle problems would be your mains level problems, and the end problems are almost advanced level problems. So I think that's a good way to solve all the problems. You start from very easy problems, you then go to move to more and more difficult problems slowly and steadily. That will help you build up your concepts also well enough. So I would suggest you just first of all take up HCV and solve it entirely. I think if you do that, that would be good enough to get a good rank in mains and even a decent rank in advance. Okay, so that is what I would suggest. But make sure you not only solve it, you understand exactly what you did in every question. If you understand every concept and how and why it was applied, then trust me, HCV alone is enough for you for to ensure that you crack advance also. Okay, but you just have to be honest while solving that book. Don't just look up solutions and say, okay, I've solved the book. So okay, so this is the approach that I'm going to get. Now let's talk about So this is what I get. If the maximum compression is this, then the block will move. Now let's see how can I find the condition for maximum compression. Okay, so when I said this is pushing this, eventually the spring force will push it back and eventually it will come to stop at some distance x. So I am assuming if x is the maximum compression, then the block would have come to rest after moving through a distance x. Now you realize if from here to here during this journey, if I apply work energy theorem, so this is my initial condition, this is the initial condition. Initial condition is this. So what do I know about the initial condition? In initial condition, x equals 0, and this is the final condition, u equals 0, and this consider is the final condition when the spring has achieved maximum compression. In the final condition, I know x equals x and v again would be 0. Why? It would move, slow down and then come to rest, and then it will start going back. So before it starts to go back, it will momentarily come to rest, and that is where the spring will be compressed by a maximum amount, right? So I know this. So now let's apply the work energy theorem. So in moving from here to here, the work is being done by friction and this force F. So these are the two forces that are doing work on your system. And in your system, you see no change in kinetic energy. There will be change in potential energy, however. So now you can use applying work energy theorem. Applying work energy theorem between my initial and final conditions. What do I know? I will see that the work done by F would be plus F into x. Why? The displacement and the force F are in the same direction. Okay. Plus there will be work done by friction. Now that will be negative. So minus times friction, which would be initially mu m1g. Okay. Into x. So this is kinetic friction. So I know it is mu m1g, and the work done by this would be minus times mu m1g x. Okay. Yes, m2 has just moved, right? I have considered this situation that at maximum velocity, it is just equal to limiting friction. It is just equal to limiting friction, so it has just not moved. If I had any more compression in the spring, even negligible compression more, then it would have moved, okay? So since my condition is that at maximum compression, the spring force is becoming equal to the limiting friction for block 2, so it hasn't moved yet. Okay, so velocity of m2 would be 0, it never moved. It would have just moved if I had just exceeded the compression slightly also. Okay, so this and all this work would have gone into the potential energy that would have been stored in the system. Okay, so this is the expression. From here I will get that F equals mu m1g plus 1 by 2 kx. So this was my first equation. This is my second equation. Now you realize from first equation I can substitute the value of kx as a mu m2g. So now let's just substitute that, since from equation number 1, kx should be just equal to mu m2g. Therefore, let's substitute that here. I will get F would be equal to mu times m1g plus mu times m2g by 2. Okay, so that is your answer. Okay, I hope you followed that. I hope everyone followed that. So this is what we did. See, so for any problem solving, the important bit is to just understand what is happening, what and why the situation that has been asked will arise. So if you can think about that, then application, trust me, will never be much of a problem. Okay, so I hope you followed the solution entirely. If there is an issue with any of these steps, if you did not follow any of these steps, then you can let me know. I will go over that again. Make sure you understand how we got the answer, how we approached it. See, more than the solution, it's the approach that is important. So make sure you're understanding the approach. Because obviously this exact question is very unlikely to be asked exactly in IIT, right? What is important is the approach. If you understand the approach, you will be able to solve thousands of questions like this. Okay, great. Next, so let's talk about conservation of mechanical energy. As I said earlier, we studied about the new form of work energy theorem. Then we will take it one step further now and we will talk about conservation of mechanical energy. So we realized that this was the form of the work energy theorem that we had. Now, in a special case, when all non-conservative forces are absent or the work done by them is zero. So I should maybe add that. Or work done by them is zero. By them is zero. In that case, you will realize that this term would go down to zero. And if this term goes down to zero, then I have delta K plus delta U equals zero, which gives us this form. And we've already realized that this is the final total mechanical energy. So this is total mechanical energy final. This is total mechanical energy initial. Okay, so thus the total mechanical energy of an object remains conserved or constant in case there are no non-conservative forces or non-conservative forces, but they are not doing any work. So please remember to apply conservation of energy only then. So whenever you want to apply conservation of mechanical energy, always check whether is there any work that is being done by any of the non-conservative forces present. If that is the case, then we go back to our previous approach. We apply this equation then. Then you don't apply energy conservation. That's the problem that I've seen with most of the students. Most of the students blindly want to apply conservation of energy without even realizing if it can be applied or not. So before applying this, you need to figure out if you can apply it or not. Okay, make sure you do that. Now, this is the problem solving strategy that we are going to take. So we realize that in absence of non-conservative forces, you can apply energy conservation. Now to solve, in such cases, identify two instances. See, like we did initially. So whenever you're applying either energy conservation or even work energy theorem, you have to apply some, you have to identify some initial instance, some initial T and some final T. So two situations you have to identify between which you are going to apply this. So the initial T would usually be according to the data, whatever is given. So you must be given some initial conditions. Initially, this is the case. This is how the situation is. So usually you will take that as your initial T. Final T, you will decide according to what is asked. Okay. So that is the most important. If you can figure out what my initial time instant and what my final time instant should be, then trust me, the rest is easy. So in such cases, you identify two instants, one according to the data given, and another according to what has been asked in the question to find. So what are you supposed to find? So that will help you decide the final condition. Now, then you just write kinetic energy and potential energy expressions for both these instants and apply the conservation of mechanical energy. That is how easy it is. That is how simple it is. Okay, so just with a little bit of practice, you will start identifying these, and the moment you start identifying these, problem solving would be super easy. So why don't we try one problem? So you've been told that an object of mass m is suspended vertically from a spring of spring constant k. It is released from its natural length. Find out the maximum elongation in the spring. Okay, so why don't you guys try this? So please remember, you have to always think about what was the initial condition, what should be the final condition. If you can think about that, then this is easy. The only tough part is doing that. So try this. Okay, one more advice. So this is what I always do when I have to solve a problem. I will always make a diagram. So if the problem has a diagram, then also I always redraw a diagram. I want to draw a diagram with my own hands so that I can see what is happening, so that I can feel what is happening. In case the problem does not have a diagram, I still go ahead and make a diagram so that I can visualize, I can picture what is exactly happening. So I think you can also start doing that practice, and that will really help you. If you can see and visualize what is happening, then problem solving becomes easier. Okay, so here let's try and understand the situation with the help of a diagram. So you've been told a block of mass m is suspended vertically from a spring of spring constant k. So this is a spring and this is the block. So block has mass m, this has a spring constant k, and you've been told it is released from the natural length. So this is how it is hanging, and initially I'm maybe holding it so that the spring is in its natural length. Now I let go. Yes, 2 mg by what is h? There won't be any h. The answer would be 2 mg by k. 2 mg h by k. No, that is not correct. That is not correct, Pawan. That is not correct. So now when you let go of this system, what do you think will happen? What do you think will happen? So think about it. Think about what is going to happen. See, if you want to think about what will happen if I just let go of the system, no, it will be 2 mg by k. 2 mg by k. It won't be mg by k. Think about it again. Think about it again. Yes, 2 mg by k is the correct answer. So imagine what is happening initially. No, Rishabh, that's the common mistake that people make. The answer is 2 mg by k and not mg by k. That is a very, very common mistake. And I will tell you why people make that. So, initially what is happening is that you have a force mg acting downwards. You do not have any spring force acting up, right? Why? Because the spring is at its natural length. So because of this mg, this block will start to go down. Now let's imagine if the extension is some y. When it has gone down by some distance y. Now it will have two forces acting on it. So one would be mg again. Mg is still acting, and now it will have an additional force acting up on it, which would be ky. So the net downward force will reduce. However, as long as realize this, as long as mg is greater than ky, the net force is still downward. So it will still accelerate downwards. The acceleration will be downwards. Now let's imagine when this becomes equal to mg. So imagine it came down even further, and let's say at some instant now that mg became equal to some kz. So let's say it has come down by z, and kz is equal to mg. Now you realize when kz equals mg, net force is 0. So which is where people think would be the maximum elongation, which is not correct. Why? Because fine, the net force here is 0, but you realize it had been accelerating all this entire time. From year to year, it had been accelerating. If it had been accelerating, then it must have a v here. So it has some v, and the net force is 0. If the net force is 0, then because of that v, it will move down even further. Now as it moves down even further and further, now you realize net force would become upward, which will cause it to retard. So next I can say that when kx is greater than mg, net force is upward. So therefore block starts to retard. Retard or slow down. And finally, there will come a condition where its velocity will become 0 because of this retardation. It will come at some place where its v would be 0. Now you realize when the V becomes 0, the net force obviously is only upward only. The net force here would be upward. Because I have already crossed this point where the net force was 0. If I come below this, then obviously spring force, which is acting upward, is higher than my mg. So when this slows down, comes to rest, now you see that the net force is upward. So now this will start moving again. Now this will start moving again. So this is where your maximum elongation would happen. This is where maximum elongation would happen. Good evening, Gaurav. So please just think about the situation. Just analyze how the motion should happen when it moves back, when it moves down. How are the forces acting? What are they doing to the motion of the block? So you will realize at maximum elongation, the block would come to rest again. Now I know that this is my initial instance. So I needed to select my two instances, right? So I will select this my initial instant and this as the final instant, because this is where I want to find the x at the final instant. Now, between the initial and the final instant, I can apply the work energy theorem. And for the sake of simplicity, I will take this as u equals 0 or 0 reference level for gravitational potential energy. For gravitational potential energy, I will take this as my 0 reference point. Now everything is very easy. So let's write the initial kinetic energy. K initial is 0 because the block is at rest. U initial is also 0. Why? Because both the spring and the gravitational potential energies are 0, right? The spring is at its natural length, so its potential energy is 0. The gravitational reference level is also right there, so the gravitational potential energy is also 0. How about my final K? Final K is again 0, as I discussed that at the maximum elongation the V would be 0 for the block. And how about my U final? U final, this block has come down by a height x from my 0 level. So gravitational potential energy would be minus mgx, and you will have a plus half kx square amount of energy stored in the spring. Okay, I hope that makes sense to everybody. See, it has come down by a distance x. That is why the gravitational potential energy is minus mgh x, and the spring now has gotten elongated by x. So the energy stored in spring would be plus kx square. Now all I need to do is apply energy conservation. So when you apply energy conservation, you realize that k initial plus u initial should be equal to k final plus u final, which would give you that minus mgx plus half kx square equals 0. And from here, it is very easy to calculate what x is. X is 2mg by k. So you will realize even in this problem, the important bit was identifying the initial condition and identifying the final condition. Once you do that, you realize writing the energies is very simple, and application of work energy expression is very simple. Okay, so this is your correct answer. Now please remember this, always first analyze and think about the situation in detail before deciding which your initial and which your final moment is going to be. As I said repeatedly, it is that bit that is going to be tough for you. Okay, once you've started figuring that out, then the problem solving is easy with work energy theorem. Alright, why don't we try another problem? So in this problem, you've been told an object of mass m is dropped from a height h on an ideal spring of spring constant k. So this span also is weightless. So consider this span to be weightless. It is a part of the spring. So this is a weightless span. Okay, or massless span, whatever. So initially the spring would be unstretched, right? Now, this block is dropped from a height h. It will hit this span, it will compress it, and you've been told if the maximum compression in the spring is h by 4, then k is. So how is k related to mg and h? So try this problem. Okay, so identify the initial. I think initial situation is always easiest to find. all you have to do is just identify what the final situation would be and what would be some parameters in the final situation. So solve that and let's see if you can give me a quick answer. So this is very similar to the previous problem, by the way. The motion when the spring starts to get compressed will be very similar to what we had in the previous problem, right? So try and solve this. This should be easy. No, Kapil. That is not even any of the options. That is not an option also. You have four options, Kapil. 12 mg by h, 20 mg by h, 30 mg by h and 40 mg by h. So how about others? Can I have some answers from others? D is the correct answer. Rishabh is right again. So yes, the correct answer is D. So well done, Rishabh. So you're getting a hang of this. Great. Yes, it is. That is correct, Rishabh. Alright, how about others? How about others? Are other people trying or do you want me to share the solution or show you the solution? Okay, so Pawan also got D. Good. Well done, guys. So that is good. See, some more practice after attending this lecture and trust me, you'll be fine. Just make sure you solve the entire HCV after this for, the work energy, except for the power part because we haven't discussed that. So try and solve every question which is related to work power and energy and trust me, you should be feeling confident after that. So let's try and solve this again. If I will assume that if the maximum compression is X, so you will realize again a similar thing would happen when it hits the pan. It will go down. It will initially it was accelerating with G. Then the acceleration would reduce. Somewhere the acceleration downward acceleration would become zero. Then the acceleration would be upwards. It will slow down, and when it reaches the maximum compression, the V would be zero. At maximum compression, you should realize V equals zero. Okay. So now all you need to do is this should be your final condition and this should be your initial condition. Again, for the sake of simplicity, I am going to take this as U equals 0 for gravitational potential energy. U for gravitational to be considered 0 here. Okay, alright, no problem, Kapil. So, initial energies. What are my initial energies? So, K initial would be 0, U initial would be 0. Why? The mass is at the 0 gravitational potential level and the spring has no compression or elongation. How about the final situation? K final obviously is again 0, as I discussed that when the spring reaches maximum compression, the mass would come to rest and then it would start moving back up. And how about the final potential energy? Final potential energy, let's see how much has this mass come down. So the mass has eventually come down by h plus x. So the gravitational potential energy would be minus mgh plus x. Why minus? Again, it is below the 0 level. Similarly, you would have had spring potential energy stored, which would be equal to half k square. Now all you need to do is apply the energy conservation. You realize that There are no non-conservative forces. The only two forces acting on the block are the force of gravity and the spring force. So both are conservative. For both, I've taken the potential energy also, so I can apply work energy theorem or energy conservation. So applying energy conservation, let's see what we are getting. We are getting that mgh plus x should be equal to half kx square. Now I was also told that x is h by 4. This had been told to me in the question. So let's just substitute that value and let's see what we are getting. We are getting mg into h plus h by 4. That will give me 5h by 4 will be equal to half k into h x square. That would be h square over 16. So this goes with this and one h goes. So you will get k equals, this is 8 into 5, which is 40 mg over h. So yes, that is the correct answer, option number D, which most of you got correct. So please tell formula for moment of inertia of a uniform disk. About which axis? About which axis, no man. Moment of inertias are always defined about some axis, and without specifying the axis, nobody can tell you the moment of inertia. Kapil, you need to be careful before answering. Naman never mentioned the axis of rotation. The moment of inertia would be different for different axes of rotation, by the way. So just saying what is the moment of inertia of a uniform disk does not make any sense. That question in itself is incomplete. You have to specify the axis of rotation, okay? Alright. Axis perpendicular to the plane passing via center. Yes, for that it will be mr square by 2. So for that, Kapil has given the correct answer. The answer for that is mr square by 2. Okay, so if you have a uniform disk and you have an axis passing through the center perpendicular to its plane, then it is, so if this axis is zz dash, then izz dash is equal to mr square by 2. So yes, that is fine. So Ananya ji says, sir, I don't know electrostats, but I still be able to learn, answer magnetism and charges, magnetism and matter. Okay, so you need to at least study the basics of electrostatics. You need to have some idea about electric fields and charges, just some idea. So maybe just read your first 2 chapters of NCERT, maybe at least that. With that, I think you can solve things. You should just have the basic idea of charge. Okay. Alright, so here is another question. 3 objects of equal mass m are thrown from a cliff of height h with equal initial velocities u or speeds u as shown in the figure. So this guy is thrown like this guy is thrown like this guy is thrown like this, and all of them are being thrown with u each. Okay, and from the top of the same, from the tower of height h. Now, which one of the following will reach the ground with highest and the least speed? So, which reaches the ground with the highest speed and which reaches the ground with the smallest speed? Yes, Pawan, all will have equal speeds, of course. So, Pawan has answered this correctly. Yes. Alright, that you can see directly from work energy theorem. From work energy theorem, if any particle reaches here with v, then half mu square plus mgh should be equal to half mov square. So which would give the same answer for v for all. Okay, so v's are independent of how they were thrown and what was the mass also of the object. So even if the masses were different also, then also the answer would have been same, wouldn't have mattered. Okay, so the speed when reaching the ground would have been same. The only thing that would have differed would be the time in which they reach. This would have reached the ground first, this would have reached the ground second, and this would have reached the ground last. But all of them would have always reached with the same speed. Okay, so great. Alright, now another major application of work energy theorem and conservation of mechanical energy is analysis of a vertical circular motion. So that is what we are going to focus on today. So how can we analyze the vertical circular motion with the help of energy conservation? That is the aim. So imagine that this was a bob which is rotating in a vertical circle with the help of a string. It is tied to a string, and because of it, it is rotating. It is being moved in a vertical circle. Now, when it is rotating, the only two forces acting on this are the force of tension and the force of gravity. Now, the force of tension is always radial and its motion is always tangential. So, this is not doing any work. So, tension is not doing any work. All the work on the object will be done by the force of gravity. So you can realize that I can apply mechanical energy conservation here because there is no work being done by any non-conservative forces. Okay. So now suppose if the initial speed was some u, the first aim is to find the velocity at any angle theta. So if it was given an initial speed u, then what is the velocity here v when it has climbed up by an angle of theta? Now all I know is that if this is my initial condition, this is my final condition. Now from initial to final, there are no non-conservative forces doing work. So what I can do is I can apply energy conservation. So to apply energy conservation, if the length of this string is, let's say, r, so let's say this length is r, then you will realize that this length would be r cos theta. Okay. Why? Because this is r, this is r. So if you look at this triangle, this is the hypotenuse, this is the base would be r cos theta. Similarly, this entire length was also r. Okay, so what is the height right now? This, I can find the height h as r minus r cos theta. Okay, now all I need to do is imagine that this is u equals 0 for gravitational potential energy, and let's apply work energy theorem between my initial and the final conditions. Okay, so let's do that. So applying energy conservation, let's see what we have. We get that half mu square should be equal to half mv square plus this guy would have had a potential energy of mgh, right? Plus mg times h, and h would be r minus r cos theta. So from here I will get the expression for v. So turns out v square equals u square minus 2gr times 1 minus cos theta. So this is the expression that I am getting for velocity. Yes, 2 not gr cos theta, gr1 minus cos theta. gr1 minus cos theta, Pawan. The height h is r minus r cos theta, right? This height h, this would be r minus r cos theta, right? So correct that. So this is the speed that I'm getting. So obviously what I will realize is that the speed is continuously decreasing. Why? As theta increases. See, initially theta was 0, so obviously you will realize that the cos theta will become 1, and you will find that at theta equals 0, you are getting v equals u, which is fine. And as your theta is increasing from 0 to 180, the cos theta will decrease from 1 and it will go all the way to minus 1 in fact. So you will realize from this expression v would be minimum at the top, obviously, which makes sense also. That is where it has the maximum potential energy. So that is where all the kinetic energy, the maximum loss of kinetic energy has happened. Most of the kinetic energy has gone into the potential energy. So as it is rising up, it is losing kinetic energy, gaining potential energy. It will have maximum potential energy at the top, and that is why it has the minimum speed at the top. Okay, so that is one expression that I got. Next, let's talk about tension at any point. So what happens if I wanted to calculate tension at theta? Now for that, what I will do is, all I need to do is take this component of mg, and this is my t. Now I know this guy has an acceleration, centripetal acceleration, right? So if it is moving with v, Then what is the centripetal acceleration? AC. I know AC equals V square over R. Okay, and which I can see that what are the forces in this direction, and using Newton's laws, I can say, using Newton's laws, I can say T minus mg cos theta should be equal to V square over R. Okay, so I hope you can realize that. So that will give me the expression for tension at any theta. So I will realize from here that T becomes V square over R plus mg cos theta. Now I already calculated my V square earlier. So let's see what my V square was. Let's substitute this value. So when I substitute, I will get T equals U square minus 2gr 1 minus cos theta over. Okay, so here, yeah, it would be mv square by r. Plus mg cos of theta. So this is what I am getting. So let's see what is it. It is mu square by r, and then I have minus 2mg 1 minus cos theta plus mg cos theta. So that is mu square over r minus 2mg. Now I can have 1 minus 3 cos theta. Okay, or 2 minus 3 cos theta. Fine. So maybe just make some more space for this. Let's just write from the start only, so that I can write the final expression also. So let's start writing from here. P equals mu square over r minus 2mg 1 minus cos theta plus mg cos theta, and that is nothing but mu square over r minus 2m. Okay, so it will be mg. I can take the 2 inside. Mg times 2 minus 3 cos theta. That is what you will get. Okay. So you realize as you're moving up, the tension is decreasing. Okay, the tension would be maximum when it is at the bottom. Why so? Let's see. So you realize this term is fixed. This is never changing. How about this term? How about this term? So you will realize that in this term you have this. So as your theta increases, your cos theta will go from 1 to minus 1. So obviously at theta equals 0, you have a minus 1 here, and at theta equals 180, you will have plus 5 here. And this is in negative sign. This is with negative sign. So that is why if the value of this increases, if the value of this term increases, then your tension will decrease. And as theta is increasing, the value of this is increasing. So what I can realize from here is that T is continuously decreasing. Okay, so T is continuously decreasing. That is what I am getting. So I can see that V is continuously decreasing with theta. T is also decreasing with theta. T also decreases with theta. So maximum T would be at this point. Okay, and for that you can write the expression T max. T max would be, let's put the value of theta as a 0 there. So what do you have? You will have mu square by r, mu square over r, and then you will have, okay, so if I put theta as 0, so this is minus 1, so plus mg. That is what I am getting. Okay, Similarly, what I am getting here the tension would be min. So T min equals, all you need to do is put that theta as 180. So when you put that theta as 180, so you will have 2 minus 3, so that is 2 plus 5, so that will be mu square over r minus 5 mg. Okay, I hope you guys can see that this is how I am getting my tension. Okay, so tension is maximum at the bottom, it is minimum at the top, and these are the expressions that I'm getting for minimum and maximum tensions. Now, if somebody asks me what is the minimum u for completing a circle, so I know that a string should not become slack if it has to move. If the particle has to move completely in circle, then the string should not become slack. So, what is the condition for string not becoming slack? The condition for that is that tension should never become zero. Okay, so I know that for completing the circle, the string should not become slack during its motion. Okay, for this T should always be greater than equal to 0. So if the tension remains greater than equal to 0, then my string does not become slack and then it can move around in a circle always. And where is the minimum tension? The minimum tension is at the top, and so just the condition for just completing the circle. Yes. Therefore, to just complete the circle, I can say that T min should be equal to 0. If T minimum is 0, then tension everywhere else would be obviously greater than 0. Okay. So, and I already figured what T min was. T min was mu square over r minus 5 mg. So, therefore, what I am getting is mu square over r minus 5 mg should be equal to 0, which will give me that u equals root 5 gr. So that is the condition, that is the initial speed. If you give this initial speed, then the particle would be able to cover the complete circle. So please remember that u here should be equal to minimum of 5 root 5 gr. If it is greater than 5 gr, then obviously I don't have any tension, but this is the minimum value. Now at this, what is V? V at top. V at top, you will realize that you can use this expression. Okay, so this was, so at top your theta is 180. So I can say V square top would be nothing but u square minus 2gr, and this becomes 2. So this is u square minus 4gr. So let's just use this result here. So V at top would be root of u square minus 4gr. That gives you V top equals root gr, which was rightly said by Pawan. So for just completing the circle, the velocity at the top the minimum velocity for Bob should be able to reach the top point. Is this correct? No, that is not. That is not. So 2 root gr you said. No, that is not correct. I will tell you why. Why? Sorry. Okay. Sorry, I have this dust allergy. I think there was dust somehow here. So V at top would be a root gr, when it completes the circle, and V at the bottom would be root 5 GR. Now, obviously, Pawan has this question that why not apply the minimum energy that is required to reach the top. Now, the point is, we don't want just the particle to reach the top. We want it to move in a circle. Okay, Pawan. So that is the difference. Agreed, agreed. So if you just wanted to make this particle reach the top, then you could have said half mu square should be equal to mg into 2r, which would have given you u equals root 4 gr. Root 4 gr would have been the minimum speed for which it would just reach the top. Okay, but but it that would have been the case if I threw it like this, vertically upwards. If I threw it vertically upwards, then it would have reached this height and come back. That is not the condition that we are looking for, right? What we are trying to find is that it should move in a circle. It should move in a circle. If it has to move in a circle, then you realize, then this is the answer. It should not only reach the top, it should reach top while moving in a circle. That is the difference. Hi, I am good. How about you? So, how was your JEE Mains advanced result? What rank did you get? Okay, did you get that, Pawan? Did you get the difference? Why you are not getting this answer? Why this is not correct? That's great. So, what was your rank and what college are you planning to go then? All India rank 33. That is awesome. Wow, that is wonderful. Wonderful. Okay. So you can go to any IIT and choose any branch that you feel like. That is an awesome result. Very well done. That's great. That's great. Good luck. Good luck with that. Okay, so yeah, Moisha got around 17,000 rank or 15,000, 17,000, something like that. So, but still, even that's a great result. Yes, I know. You told me earlier only that you are getting a top 100 rank for sure. I know. So very well done. Congratulations to you. Now relax, enjoy your time before joining the college. Okay, so which you already have a lot of time, I think, before the online classes at least start or before you go to the campus. So I'm sure have a good time and enjoy your college life to the fullest. Okay, so that is going to be my advice. So try new things in your college. Keep your focus on studies, but try new things also and have fun in your college life. Okay. So congratulations once again and good luck for your future. All right. Okay, so Pavan, as I was saying, I hope you got the answer of this. Pavan, did you get why we are not using root 4 gr or 2 root gr, which you thought would be the correct answer? You're always welcome in my classes. All right. So why don't we try a problem? Why don't we try this problem? Okay. So let's see. A particle of mass m is attached to an inextensible light string and is moving. A particle of mass m attached to an inextensible light string is moving in a vertical circle of radius r. If the speed of the particle at the bottom is twice the minimum speed required to complete the circle, then find the tension in the string when it becomes horizontal. Okay, so try this. Try this, guys. So what would be the tension when it becomes horizontal? Let's see. Okay. Are you not trying this, Rishabh? Where are you going? Okay, okay, no problem. Okay, how about Pavan? How about others? Please try this. Yes, of course, hard work always pays off. Hard work always pays off. Now all you got to do is just relax and enjoy this time. And trust me, you are probably sorted for your entire life now. So yes, trust me, that hard work is not only worth, it is feeling good right now. Trust me, you will thank yourself for this hard work and those sleepless nights for your entire life, because it will make your entire life different. So that is what I keep telling all the students, that if you work hard right now, trust me, it is going to pay off for your entire life. It changes the entire course of your life. So definitely, even if you have to go through some pains, some if you have to make some sacrifices, at the end of the day, it will be all worth it. Yeah. So now it's the time for you to relax, celebrate, and just have fun for a bit before your college starts. And trust me, I mean it's unfortunate that I don't know when are you going to attend to be on campus. So when are you going to go to the campus? Trust me, going to the college campus is another experience. The campus life is a completely different and wonderful experience. So just wait for that. Trust me, it's that is going to be another wonderful experience of your life. And that is something which will stay with you again for your entire life. So I don't know how many of you know this, that I used to be a big time introvert till my class 12th. Used to have a huge stage fear, by the way. Okay, so 5 mg. That okay. Let's see. So I used to have a big time stage fear, by the way, and I like the class that I'm taking right now online. Trust me, I wouldn't have been able to take it earlier, and even live classes when I would take. Trust me, I wouldn't have been able to take those also. When I went to IIT, I tried a lot of things. I tried stage plays, and I tried a lot of I took part in a lot of competitions because I wanted to get rid of those inhibitions that I had. And so I was in the dramatics team of IIT Delhi, by the way. So yes, that is how I got to be a completely extrovert person from an introvert. And that experience was amazing. It has helped me in life. It made me a much more confident person, and it even helped me here in teaching. All right. So trust me, the experiences that you have in your college life, in your hostel life, they will shape up your personality. They will shape up the kind of person you are, and has a great impact. You can choose to be a completely different person than what you were before you entered IIT. So trust me, it's a wonderful journey. It's a wonderful metamorphosis that you go through as a young man. Okay, so good luck for that, and I hope you come out of the college becoming a wonderful guy. So let's see. So here you've been told that the initial speed was u equals 2 times root 5 gr. Then obviously when you reach here, then you can apply work energy theorem, and you can find the V. So you don't really need to memorize these expressions, by the way. You don't need to memorize these expressions. I don't remember these expressions. All you need to memorize is, by the way, this. This you should memorize. This is the standard result that we use. So this you should remember. So whatever I highlight in yellow, that is the only part you need to memorize. So this is a very standard result which we use very, very often. These equations, no need to memorize. You should be able to calculate them whenever they need be. So let's see, if I apply the work energy theorem, then I will get half mu square equals mgr plus half mv square. So that will give my, okay, so mv square equals mu square minus mgr. So that is m into 4 into 5 gr minus 2 mgr. So mv square becomes equal to 20 minus 2, that is 18 mgr, which means mv square over r equals 18 mg. And when this guy is here, then the only force acting on it is the tension. So this should be equal to T, by the way. So the answer that you should have gotten for T is 18 mg and not 5 mg. Read the question carefully. It says, find the tension in the string when it becomes horizontal. Did you calculate the tension when it is at top? Did you do that? Let's see what you did. Let's find out the tensions at different places also, and then I will tell you a small trick. So tension here is 18 mg. So what is the tension at the bottom? Let's calculate that. So this is T at horizontal. What is T at bottom? T at bottom would be, you realize you will have T, you will have mg, and you will have half. Okay, so T minus mg, T bottom minus mg equals mu square over r. So from here you will have T bottom would become m by r into u square would be 4 into 5 gr plus mg. So that will be 21 mgr, 21 mg. I think so. Even in I think mains, he had a very good rank in the top some. He had a 3-digit rank, and he was very confident before his advanced result only. So obviously, I think he might be telling the truth. I don't know. I did not check the result personally, but that is what he has told me. So, and I believe it. Must be correct. Okay. So T at bottom turns out is 21 mg. Now let's calculate T at top. So at top you would have had tension, you would have had mg, and you would have had a V here. Let's calculate Vt. So I can calculate my V top as half mu square should be equal to half mv square plus mg into 2r. So that will make mv square equals mu square minus 4 mgr. So that will be 20 minus 4, that is 16 mgr. Okay, so that is 16 mgr. So, and I know T top, similarly T top plus mg should be equal to mv square by r, and mv square by r from here I will realize mv square over r is 16 mg. So what you were saying, Pawan, is probably the tension at top. Tension at top is 15 mg. You are right about that. You are right about that. But that is the tension at the top. What had been asked in the question was tension at the horizontal. Okay. Now I wanted to show you one thing very, very interesting. That when you're moving in a circle, vertical circle, you realize here T bottom comes out to be 21 mg. T top was, let's say T horizontal was 18 mg, right? Now I could have directly told you what the T at top would be. Okay, this is a trick, remember this. So if from bottom to horizontal, you see the tension has gone from 21 to 18. So it has decreased by 3 mg. From here to here also it will decrease by 3 mg only. So the answer directly would be 15 mg. Okay. What is that? So that is the trick, by the way. And if you wanted to calculate the tension at 45 degree, so imagine, guess how much will that be? So from here to here, delta T was 3 mg. Now it has only climbed half the height, right? Half the height. Delta T would be 1.5 mg. So here I can directly say T would be equal to 19.5 mg. You can verify that. Oh, okay. So is that what you're saying? Yes. No, but the trick is that the delta T is corresponding to the height. From here, at 45 degree here, you would have realized that the T would have been 16.5 mg. That is the trick that I'm telling you. You can easily remember this. So you have to find the difference. So the tension always decreases by 6 mg when you go from top to bottom. So tension at the bottom, if it is 3 mg, then it will not be able to complete a circular motion. Now let me tell you here also, T bottom. So if you realize T max, how much is this? If U equals root 5 gr, you will realize T max would be equal to 6 mg. And in that case, you will realize that here T top becomes 0. So from bottom to top, the tension always decreases by 6 mg. And at the middle, it would have been 3 mg. You can check that. This is the trick that you can use. Okay, Pawan. So transmit tension at bottom minimum can be 6 mg if it has to complete a circle. Yes. If the tension was only 3 mg, then it would just reach this height. It won't complete the circle. Okay, now you remember this trick. And this will help you solve some problems very, very easily. So from bottom to top, delta T is always 6 mg. And for any corresponding height, the change in tension would be in that ratio. So at the middle point, at the horizontal point, the delta T would be 3 mg. At 1/4 of the height, the delta T would be 1.5 mg, and so on. So you can use this shortcut, this trick, if you ever need it. Okay, this is an interesting fact, very interesting fact that you can use. Okay, so that is it, guys. That is what I wanted to talk about today. Remember, these tricks, these shortcuts will help you solve your problems quicker. Okay, this is a very simple fact which you can easily remember. Okay. So again, before I leave you, let me remind you that you should be getting your Unacademy subscriptions if you haven't gotten them already, and this is how you do it. You go to the plus section of your app, you select your goal as IIT JEE, and you click on that get subscription button. Alright. And when you're getting your subscriptions, make sure that you're using this code RD Live. If you use this code RD Live, then you will get a flat 10% off on all these subscription fees, and then you can proceed to pay. Next, if you like today's lecture, then press the like button and share it with as many people as possible. Why? Why is that? Why are you unable to practice enough? See, my advice would be, so if I'm taking the lectures on Wednesdays, Mondays and Fridays, so right after my lecture in the evening, maybe at night, just revise the lecture once and solve at least 15 to 20 problems that same day. Okay. So maybe you can divide the time. As I said, see, you have already watched this video. You can revise this video within 30 minutes. All the concepts that I talked about, maximum it's going to take you 30 minutes to revise. And then just take 1 hour of practice. 1 hour of practice, 1 hour. In 1 hour, try and solve around, let's say 10 problems. At least keep doing that. Okay, you have to find out 1.5 hours daily. And then it should be fine. See, so physics you can only do on alternate days also, no? Since my class 11th lectures are happening on Wednesdays, Mondays and Fridays, so on those days, you can revise your class 11 physics. See, it's always best to just practice along with your studies. When you are studying a concept, if you practice right there and then trust me, this concept also becomes stronger in your head and you remember it for a longer time. Okay, so that is my advice. Rest up to you. Whatever time you can find, whatever time you can dedicate. Anyways, as I was saying, please try and share this video with more and more people because this is quality content absolutely for free, which we are providing to students who can't afford these subscriptions. So make sure more and more students benefit from this. Yes, do that. Trust me, you will be able to find that time. Don't forget to press the bell icon, and the PDF of all the slides used in today's lecture would be available for download very soon. For that, you will have to be a little patient. We are working on it. We are getting all the PDFs sorted. Actually, there was a lot of confusion about all the PDFs. We had uploaded them and everything got mixed up. So we are trying to sort all the PDFs, and the PDFs would be available for download within a week's time. Again, those of you following us on the JEE English channel can please connect with us on the Telegram app using that link. Finally, before I leave you, let me remind you one more time. Get your Unacademy subscription if you haven't gotten it already, because this will give you all the help that you need. This is a highly competitive exam. You will need as much help as you can get. Okay, so what's the example of inertial non-conservative force? So, what do you mean inertial non-conservative force? So, friction maybe. How about friction? There is nothing like inertial force, by the way. There is nothing like inertial force. There are conservative forces, there are non-conservative forces. There is nothing like inertial force or non-inertial force. There is force and pseudo-force. Internal. Okay, internal non-conservative force. So internal could be internal friction. A lot of things. For instance, in real life springs, these parts of springs have friction between them. So those would be internal non-conservative forces, right? So internal friction of a spring coil can be an internal non-conservative force. Okay. Yeah, got it. Sorry, I read it wrong. I hope you understood that. Okay, got it. So that is an example of an internal non-conservative force. So in real life, you know that all these springs, when you press them, they do not exactly come back to their natural lengths or do not exactly release all these potential energy stored. Some of that will get spent against the work done in internal friction. So that is an example of an internal non-conservative force, okay? Alright, so as I was saying, don't forget to use this code when you're getting your Unacademy subscription, and this code will give you a 10% off. So I will see you next on Friday. Till then, you guys keep practicing and keep studying. Take care and bye bye.